It was supposed to be untouchable. A 15-car Russian fuel convoy hauling over 1,000 tons of diesel, rolling deep behind the lines. Guarded by jamming stations, shielded by air defense, hidden under darkness. And yet in just minutes it burned. What followed wasn't just a precision drone strike, it was a seismic rupture in modern warfare. For $8,000 in gear, Ukraine shattered $4.2 million in armored logistics and exposed deep fractures in Russia's electronic warfare shield. This wasn't luck, it was doctrine. Adapted, tested, perfected. And somewhere in the silence above the battlefield, NATO and US satellites were watching, taking notes. So what happens when hobby drones' encrypted links and fiber optics can outwit a superpower's defenses? Buckle in, this isn't a simulation. This is the future of war. Don't just watch, engage. Hit like, subscribe, and comment if battlefield innovation matters to you. Your insight fuels this mission. They had just 20 minutes. That's how long the Russian electronic warfare grid flickered, barely a hiccup in a system built to blind satellites, scramble drones, and mask battlefield movement. But for the Ukrainian Special Reconnaissance Team, watching from a dusty forward ops post, that glitch was everything. For 96 hours, modified DJI quadcopters no bigger than a backyard toy had patrolled the skies invisibly. Outfitted with encrypted Starlink uplinks and flown from concealed positions, they painted a picture of a 15-car Russian fuel convoy snaking across contested territory. It wasn't just fuel, it was operational lifeblood. Each tanker car carried enough diesel to power a full tank battalion for 72 hours. Intel analysts confirmed the math destroyed the train, and you don't just hit logistics, you fracture the tempo of entire regiments for weeks. But the target didn't sit still. It moved beneath a veil of jamming towers, LER-3 trucks, and overlapping short-range air defenses. Timing had to be perfect. Just one mistake could tip the balance and trigger a Russian counteroffensive, or worse, leave NATO with an embarrassing unanswered escalation. Inside the field shelter, two drone operators scanned telemetry. One watched the signal stability, the other tracked heat signatures from the locomotive's exhaust plume. The rail line curved east toward an aging viaduct, a predictable slowdown point. And that's when the window opened. Russian radar feeds lagged. The air defense envelope dropped. And somewhere in a Warsaw operations center, a NATO satellite marked the zone green. Within minutes, the first drone launched, low, silent, hugging the terrain. Not a single RF burst, not a ping. It ran cold. Because this time, it wasn't using radio at all. It was flying on glass. A 9-micron-wide fiber optic tether unspooled behind the drone like spider silk. Unjammable. Undetectable. Direct line-of-sight control from the operator's console at the cost of stealth, but with perfect stability. This wasn't improvisation. This was a surgical blueprint built from battlefield data, Western doctrine, and cold precision. The strike team exhaled. The kill chain had begun. The first drone didn't just fly, it glided like a surgeon's scalpel across a chaotic battlefield. Underneath its carbon fiber shell, the drone carried a customized payload, a PG-VL high-penetration shaped charge, refitted for aerodynamic release. Originally built for anti-armor RPGs, the warhead had been adapted by Ukrainian engineers to ignite fuel tankers with brutal efficiency. A conical liner shaped the explosion into a superheated jet over 35,000 feet per second, capable of slicing steel like wet paper. But the real genius wasn't the warhead. It was what the Russians couldn't see. The drone flew without emitting radio signals. Instead, a 9-micron optical fiber, a strand thinner than a human hair, trailed behind it. Operators controlled every twitch of its rotor, every yaw correction through light pulses carried in that glass strand. No electromagnetic emissions, no heat bloom, no ping on Russian spectrum analyzers, and the Russians were watching. Parked on a ridgeline 12 kilometers away, a LER-3 electronic warfare vehicle scanned for drone signatures. It was their crown jewel, capable of spot jamming, wideband scrambles, and signal flooding. And it was completely blind. The drone flew beneath its gaze, weaving between pine trees and low hills. As a fail-safe, Ukraine had launched a decoy swarm of cheap quadcopters built from commercial parts on a parallel path. Those decoys carried standard RF links on purpose. As they pinged the spectrum, the LER-3 reacted. Its operators lit up the valley with jamming signals, and redirected attention away from the real threat. In reality, the true drone was already locked onto car number 4. But this wasn't just a single miracle drone. The entire swarm, 6 strike units, and 4 recon drones had been rebuilt in a clandestine workshop west of Dnipro. They were upgraded with 56.6 optical zoom lenses capable of reading license plates from 3 miles out, 45-minute extended batteries with cold weather regulation, rotating signal obfuscators designed to mimic birds in IR spectra, adaptive frequency hopping algorithms shifting up to 1/500 times per second for backup non-optic units. And in one of the riskiest adaptations, operators had installed thermal displacement wings, composite fins coated in reflective material that distorted the drone's heat signature during descent. The goal beat IR-guided countermeasures on final approach. Every drone was a scalpel, but together they formed a doctrine, a hybrid of NATO data discipline and asymmetric Ukrainian courage. Still, not everything went according to plan. Drone 3, codenamed Spectre, encountered turbulence from a sudden heat vortex above the train cars. The firestorm from the first explosion had created thermal winds stronger than a Category 2 hurricane. Spectre's stabilizers failed momentarily, causing it to spin and drag its fiber tether across smoldering diesel. Inside the command post, the drone pilot's monitor went blank. A heartbeat passed, then another. But the line held. The fiber optic link burned blistered, still carried light. Operators switched to manual override. With only 28% battery left, Spectre limped back into position. Its warhead wouldn't eject properly. That's when the pilot made a call no algorithm could predict. "Push it in," he whispered. Spectre dove nose first into a puddle of diesel beside car number 6. The impact crushed the warhead housing, but ruptured the tank's exterior. Seconds later, a delayed ignition turned the drone into a flying incendiary. Another wave of flame erupted, pushing temperatures beyond safe limits. But this chaos helped the remaining drones. Russian gunners panicked and, blinded by smoke, missed 2 more incoming UAVs. Cars number 8 and number 11 were hit with precision, sending gouts of flame hundreds of feet into the air. And then came the kill shot. The final drone, heavier than the rest, had one mission: disable the locomotive. Flying in low with just 12% battery, it nosed under the engine compartment and triggered its payload. The entire rail section heaved. Steel twisted, diesel flooded, communications ceased. And with that, the mission crossed from precision strike into strategic disruption. At precisely 03:14 local time, the first drone struck. The shaped charge didn't just puncture the armor, it atomized it. The impact point was car number 4, located dead center in the 15-car convoy. It carried 70 tons of diesel, all pressurized, all stacked above the rail heat. The warhead's jet screamed through the tank wall at 35,000 feet per second, igniting a chain reaction that engineers had only theorized until now. The tanker exploded inward first, then outward, lifting the steel chassis off its bogies before it disintegrated in a rolling column of flame. It wasn't a burst, it was a rupture. But the true horror wasn't just the fire, it was the air. The tanker cars were interconnected by ventilation tubes designed for pressure regulation during fuel loading. Those same connections became arteries of death, carrying the fire like napalm from one car to the next. The inferno spread in seconds. Operators watched in stunned silence as real-time thermal imaging bled across their monitors. A chain of reds turned into pure white heat. The entire center of the convoy became a furnace. Operators on the ground were struck with a problem no one had planned for: visibility. The flames were now so intense that drones couldn't navigate through the heat distortion. GPS was unreliable. Battery reserves plummeted as cooling systems failed mid-flight. And yet the mission continued. Drone 5, callsign Vandal, was hit by small arms fire as it looped in from the western ridge. A Russian infantry element, likely from a railguard platoon, had emerged from a forested outpost and opened fire with 5.45 mm Kalash rounds. At 200 feet, one round caught the lower fuselage, disabling Vandal's altitude sensor. Altitude control failed. The drone spun. The operator, a 27-year-old former IT technician turned UAV pilot, made a snap call. He killed altitude lock, switched to manual throttle, and angled the drone by visual reference, alone an impossible task in full thermal bloom. And yet he found a target: spilled fuel pooling beneath the still intact car number 9. He rearmed the warhead manually. There was no time for retargeting, no GPS lock, no optics, just blind instinct. He nosed the drone downward at 22 degrees, throttle full. Impact. A second explosion tore through the lower rail lines, buckling steel, tossing ballast rock like shrapnel. Surveillance drones from NATO high-orbit relays caught the light bloom from 400 miles up. Inside the Ukrainian bunker, the feed went dead. For 14 seconds, there was nothing. No image, no sound, just silence and a plume. Then the heat cleared. The train was gone. Only 5 of the 15 cars remained even remotely intact. The rest were molten charred, scattered across 600 yards of track. The locomotive had been thrown off the rails by a late-strike drone that pierced the undercarriage. Flames climbed 200 feet. The sky over Donetsk glowed like a second sunrise. Russian command posts scrambled to respond, but they were blind. Their EW units had flooded the spectrum so aggressively that they were jamming their own communications. Internal chaos reigned. What remained of the Russian rail patrol was either in retreat or consumed. Ukraine hadn't just destroyed a target. They'd rewritten the formula. At 1:03:11 a.m. local time, 3 minutes before the first explosion, an MQ-4C Triton surveillance drone flying at 56,000 feet above southern Ukraine picked up a faint signature on its synthetic aperture radar. It wasn't the fuel train. It was the optical tether. At first, analysts in the NATO Joint ISR Command Center in Ramstein thought it was a glitch. A vertical thread of infrared shimmer, no wider than a pencil, trailing something beneath the canopy of Ukrainian trees. Then they saw the pattern, a linear control route, unbroken, feeding live telemetry without a single electromagnetic
They should
pulse.
stay out of Ukraine's swamp. But here's where things get interesting in the worst possible way for the Russians. When that jet hits the fuel car's steel wall, it doesn't just penetrate. It literally liquefies the metal and pushes it aside like a hot knife through butter. The fuel inside doesn't have time to leak. It vaporizes instantly, creating a pressure wave that treats the car's structural integrity like a suggestion. The explosion rips through car number 4's interior at temperatures exceeding devastation comes from something Soviet engineers never anticipated: the interconnected ventilation systems between fuel cars. What was designed for pressure equalization during loading operations now becomes a highway for destruction. Within 20 seconds, burning fuel vapors have ignited cars number 3 and number 5, turning 3 separate targets into one massive fire. Russian crew members finally spot the second attack drone approaching car number 8. Their response is immediate and completely ineffective. 5.45mm rounds at a target moving 160 kilometers per hour and maneuvering in 3 dimensions. It's like trying to shoot a hummingbird with a shotgun while riding a mechanical bull. The small arms fire forces the drone into wild, evasive maneuvering, but the operator maintains control through the chaos. Meanwhile, the first drone-shaped charge decides to demonstrate that Ukrainian engineering isn't always perfect. Instead of the clean penetration expected, the warhead achieves only partial detonation, leaving car number 4 ruptured but not completely destroyed. The operator, watching through crystal-clear fiber-optic video, makes a split-second decision that's equal parts brilliant and insane. He guides the drone's burning wreckage directly into the spilled fuel, using the drone itself as an incendiary device to complete the job. Then physics intervenes in ways nobody anticipated. The massive fire creates its own weather system, characterized by thermal convection currents that generate updrafts and downdrafts, with wind speeds exceeding. Attack drone approaching car number 11 suddenly finds itself fighting hurricane-force winds generated by its own mission success. But the problems compound when the second drone's fiber-optic cable snags on a railway signal post, limiting its maneuverability. The operator now faces an impossible choice: abort the attack and waste months of preparation, or attempt a precision strike while tethered like a flying yo-yo. He chooses the latter. The locomotive engineer applies emergency brake stop on command, but normal circumstances don't include multiple fuel cars burning at temperatures that can melt copper. The stationary train just became an easier target. As car number 4 transforms into a fireball, the massive blaze creates convection patterns that turn the remaining attack runs into aerial knife fights. The second drone operator fights cable tension, wind shear, and small arms fire while lining up his shot on car number 8. In 33 seconds, he'll discover that sometimes the hardest part of precision warfare isn't hitting your target, it's hitting it while everything else is literally on fire. Fights convection currents rising from the burning fuel cars. Wind shear from the thermal column throws his approach, forcing a desperate course correction as small arms tracers streak past his camera feed like angry fireflies. But the fire doesn't just create wind, it creates something else entirely. The massive fire smoke particles scatter laser designators and degrade visual targeting, while the heat shimmer throws off IR sensors. The operator finds himself flying essentially blind, navigating by thermal signature alone through a self-generated hurricane of superheated gases. Meanwhile, the fourth drone operator faces a different nightmare: battery degradation. Ukrainian engineers optimize these drones for endurance, but fighting wind resistance from thermal updrafts drains batteries faster than anyone calculated. He has one chance to reach the locomotive, or his drone will fall harmlessly into the countryside. The second drone, still fighting the snagged fiber optic cable, approaches car number 8 like a tethered falcon diving for prey. The cable tension affects thermal velocity calculations, but the operator compensates with pure flying skill. At a closure rate of 60 meters per second, he has exactly 1.3 seconds to adjust the cable drag before impact. The simultaneous strikes come moments later. Drone number 2 slams into car number 8, while drone number 3 targets car number 11, their shaped charges detonating within milliseconds of each other. The overlapping blast zones create constructive interference, pressure waves that amplify rather than cancel, turning two separate explosions into one sustained detonation. However, the real devastation lies in what happens next. The cells, designed for 60-ton locomotives, start warping under thermal stress that exceeds their engineering specifications by 300%. What was once precision transportation infrastructure becomes twisted metal sculptures that would be perfect for a modern art museum. The fourth drone, running with 8% battery remaining, executes the mission's final strike against the locomotive. The operator has no margin for error, misses his shot, and a $2.4 million piece of rolling stock survives to haul more fuel tomorrow. The PG-7V